So how can we measure the purity of decision tree split using the Gini index? What is the mathematical explanation of it? Folks, Nitin here, and this is the AI University channel. In this video, I'm going to talk about Gini index and explain the mathematics around this technique. I'm also going to show you the steps to measure the purity of decision tree split using this algorithm. This is one of the most used algorithm or splitting criterion in decision trees, and knowing the mathematics behind it is of utmost importance if one of the machine learning model you are developing is a decision tree. So watch this video till the end to get the complete details. If you are new here, then consider subscribing to this channel, or if you have already subscribed, then click on the bell icon to receive the notifications about hottest technologies of 21st century. GitHub link for all the required Jupyter notebooks is given in the description section as well as at the end of the video. Please don't forget to like and share this video. The Gini index is used in the calculation of income inequality or disparity, wealth distribution among the population, diversity in nature and society, etc. The Gini measure gives the probability that two items chosen at random from the same population are in the same class. For the pure population, this probability is 1. Let's compare the Gini score for the two splits we discussed in the previous video. First, we will calculate the Gini score for the parent node. So as you can see, the parent node has 8 red data points and 8 blue data points. The proportion of red and blue data points is 0.5 each, because 8 divided by 8 plus 8 is 0.5. The Gini score for this node is going to be the sum of square of the proportion of red and blue data points. In this case, it is the square of 0.5 plus square of 0.5, or 0.25 plus 0.25, which is equals to 0.5. Hence, the Gini score for the parent node is 0.5. Let us now examine the first split. The Gini score for the left node is calculated as follows. Number of red data points equals 2. Number of blue data points equals 0. Proportion of reds equals 2 divided by 2 equals 1. Proportion of blue equals 0. Gini score for this node is equals to square of proportion of red data points plus square of proportion of blue data points, and which is 1 square plus 0 square, which is equals to 1. Now let's calculate the Gini score of the right side node. So the Gini score for the right node is calculated as follows. Number of red data points equals 6. Number of blue data points equals 8. The proportion of red data points is equals to 6 divided by 8 plus 6, or 6 divided by 14, which is equals to 0.43. Proportion of blue data points is equals to 8 divided by 6 plus 8, or 8 divided by 14, which is 0.57. Gini score for this node equals 0.43 square plus 0.57 square, which equals 0.510. Now, in order to calculate the Gini score for the split, we need to weigh both the nodes' score by the proportion of records in each node and then sum the weighted score. The first node has 2 data points out of total of 16. So the proportion of data points in this node is 2 divided by 16, or 0.125. Please remember that the Gini score for this node was 1. Now the proportion of data points in the second node is 14 divided by 16, or 0.875. The Gini score for this node was 0.510. So the Gini score for the split is 1 multiplied by 0.125 plus 0.510 multiplied by 0.875. The Gini score for this split thus is 0.57. Let's now examine the second split in the similar fashion. The Gini score for the left node is calculated as follows. Number of red data points equals 6. Number of blue data points equals 2. The proportion of red data points is equals to 6 divided by 2 plus 6 equals to 0.75. Proportion of blue data points equals 2 divided by 2 plus 6 equals to 0.25. Gini score for this node equals square of proportion of red data points plus square of proportion of blue data points, that is 0.75 square plus 0.25 square, which is equals to 0.625. The Gini score for the right node is calculated as follows. Number of red data points equals 2, number of blue data points equals 8, proportion of red data point is equals to 2 divided by 2 plus 6 or 2 divided by 8, which is equals to 0.25. Proportion of blue data point equals 6 divided by 8, which is 0.75. Now the Gini score for this node equals to 0.25 square plus 0.75 square, which is equals to 0.625 again. Let us look at the Gini score for this split. The first node has 8 records out of total of 16. The proportion of records in this node is 8 divided by 16 or 0.5. The Gini score for this node is 0.625. The proportion of records in the second node is 8 divided by 16 or 0.5. The Gini score for this node is 0.625 as well. So the Gini score for this particular split is 0.625 multiplied by 0.5 plus 0.625 multiplied by 0.5. The Gini score for this split thus is 0.625. Since the Gini score for the second split is higher, that means that this split will be chosen by the Gini method as the optimum split. So folks, this is it for this video. In the next upcoming video, I will cover another method to measure the purity of a split in decision tree when the target variable is categorical in nature. That method is information gain. So stay tuned. Here is today's question. State true or false. The Gini index is used in calculation of income inequality or disparity, wealth distribution among population, etc. Please post your answers, comments in the comment section given below so that I can get a chance to incorporate your feedback. You can also post your technical questions in the comment section and I will try to answer the same. If you are watching this video and you are not already a subscriber to our channel, consider clicking that little subscribe button. In case you have already subscribed, then click on the bell icon to receive the notifications whenever I will release a new video. So thanks for hanging out with me guys. I will be covering next topic in the upcoming video, so keep on watching. Thank you.